Today we're going to look at estimating fractions. Open up your fraction flipbook to the very first section titled Estimating. First, let's look at the first example, example 1. We are estimating the sum of 1/3 and 5/9. Now we're going to use benchmarks to help us make sense of this estimation. So I'm going to mark off here my benchmark 0, 1, and then halfway in between is a benchmark of 1/2. It's useful to put these benchmarks on a number line to think about what happens when we add these two fractions together. First, I'm going to look at 5/9. I recognize here that 5/9 is just a little bit more than 1/2. And the reason I know this is that half of 9, which is the denominator, is 4.5. Since I have 5/9, I have just a little bit more than half. So I'm going to show that with this arrow and my number line. Next, I'm going to add 1/3 to it. So if I add 1/3, I'm going to be just a little bit less than a whole. So my estimate here is going to be a little less than 1. In example 2, we are finding the difference here, or estimating the difference of 3/4 and 1/8. So 3/4 I know is, let's see if I put these benchmarks here, exactly halfway between 1/2 and a whole. Equal distance here. So it's hard for me to decide if I want to overestimate 3/4 or underestimate 3/4 without looking at what else is happening. If I start out here at 3/4, the next thing I'm doing is subtracting 1/8. So if I subtract on the number line, I move back to the left here, or back towards 1/2. So that now shows me that this estimate here is actually closer to 1/2 than it is a whole, because I'm subtracting just a little bit. So my estimate here is a little less than 3/4. In example 3, we're going to look at estimating multiplication of fractions. So remember, a part is a proper fraction or something that's less than a whole. So in this case, I have two proper fractions, 1/3 and 3/4. I'm taking a part of a part. Whenever we do that, our answer will be smaller than either of the original fractions or parts. You can see that in this brownie pan model that I have here for you. I'm going to represent 1/3 by dividing this into 3 parts and shading the 1/3 in blue. And next I am taking 3/4 of it, or 3/4 of the 1/3. So I'm going to divide the 1/3 into 4 parts. And I need to shade in 1, 2, 3 of those parts. So you can see here the shaded parts are much smaller than the original dark blue 1/3. So a part of a part will be smaller than either part. So my estimate here, since 1/3 is the smaller of the two fractions, my estimate is going to be less than 1/3. If we look at the next multiplication problem, we're taking a mixed number, 2.5, and we're multiplying that by 7/8, which is less than a whole, so that is my part. Now I'm taking part of a mixed number, so that answer will be smaller than the mixed number that I started with, but larger than the part itself. So if you look at the brownie pan models here, I'm showing 2.5, and when I take a part of it, I'm dividing that into 8 parts, and I'm shading in 7 of those 8 parts in each of those models. So you can see that the new shading here represents less than the 2.5 that I started with. So my answer here is going to be, if I want to take part of 2.5, because my part is pretty close to 1, I'm going to say my estimate here is a little less than 2.5. I got that weird mark there. And then finally, the last problem, example 4, is a division problem where we're taking 2.5 and dividing by 7/8. So when you see a division problem like this, I want you to ask yourself how many 7/8 can fit into 2.5. Well, 7/8 is almost 1. So if I wanted to estimate 7/8 to be about 1, and then I were to actually divide 2.5 by 1, that answer would be 2.5. But remember here, the size of my group is not really 1. The size of my group is smaller than that. So if the size is actually smaller, I should be able to get more groups. So my answer here is going to be a little more than 2.5. And that's it for estimating.